Hi, welcome back. Let us continue. Okay, in previous sessions, I did explain to you what is this method and why, how to calculate the work in general. Okay, now we're going to calculate line integral. The line integral basically is a calculation of the work. We're going to calculate for the line in a dynamic way for the line for the movement of charges. Okay, the movement of charges in the form of a line. We're going to call it that as a line, but basically it's a tiny movement. We're going to project how to calculate the tiny movement of the any particles. Okay, in order to calculate that any particles in the form of small tiny line, we need to learn what we call it that as a length of plane curve. Okay, length of line. Okay, earlier I did explain to you, we already learned how to calculate the through integration. Okay, we learn through integration. For example, to the a to the b, we calculate the a to the b of any the equation of this for the particular case, then we able to calculate the whole what you call area. But now we're going to calculate only the length of the curve. Okay, the length of the curve or the plane curve. Okay, this is, we call it as a line. Let me cover with you this topic slightly, and this topic is not in the syllabus, but I feel this is very important to know in order, because we're going to incorporate this calculation later. Therefore, although the syllabus not directly covering this topic, I feel this is very important for me to explain to you, because we're going to embed this formula inside the our calculation for the method, the continuous method that I'm going to introduce to you. Therefore, let me cover slightly a little bit about this the length of plane curve. Okay, this is very important to know. Therefore, I just it's not deviate, I just to cover additional information for you, which will help you to understand the whole calculation, the length at line. Okay, I will move it a little bit faster bit. Okay, to calculate, in order to calculate the length of plane curve, okay, is it possible for anyone to calculate the length? Okay, if there is a case like that, which is control and which can be drawn using a fx here, okay, then I would like to calculate, let's say, the length of this from A to the B. Okay, now let me divide this segment into the equally sized. Okay, equally sized, and it can be infinite. Okay, it can be infinite level then, but at the moment I call it this x2, x1 and xk minus 1, and okay, let's continue. Imagine there are a lot of segment here. Okay, maybe I'll just put it that as a continue, then I call it here xk minus 1, and this is xk, and continuing from there. Okay, if this is the scenario, let me call it this as P1, this is a P2, and okay, continue up to here PK minus 1 PK. Okay, is it possible for me to calculate the okay, the difference here? Okay, the different size, the size can be fixed. We are fixing this, and this referring the size, the sizes can be defined as x x k minus 1 minus this can be k x k minus 1. Okay, this is simple, that is very simple. Just the difference can be but remember, this is fixed. This is fixed for every segment here. Okay, once we calculate this, is it possible for me to calculate this segment here? For example, PK, difference between the PK here. Okay, can I calculate this? Okay, what is this? Actually, this is, you should imagine this as a something like a theorem Pythagoras. Okay, imagine there is a line moving, but okay, slightly small. We imagine this is a small segment change here, and this is a fixed line. Okay, and this one can be a PK1 and PK. Okay, therefore the difference here and the difference here will determine this, right? Therefore this is theorem Pythagoras, and I hope that you can understand this very easily. Okay, xk minus xk minus 1. Okay, this is the difference. Okay, I'm taking this part, therefore plus yk minus 1 over 2. Okay, call it this as equation number 1. Okay, now as we know from the previous lesson that we used to learn here, let's say if I limit the del x to something to the 0 level, and if it is f for the k, let's say in a particular k point, and this can be defined as a differentiation, right? If it is a continuous line. Okay, this is what we learned. Okay, this is what we learned for the limit x approaching to the 0 for the xk, that we can define this as something, the differentiation. Therefore, we know the combinations, this portion, we can define, imagine lah, okay, this is, okay, I just put it to, okay, it's approaching to this, but I need to do the calculation here. Then in this particular case, we can say for the del f prime differentiation of this xk is something called yk minus 1, which is differentiate with this, divide with the xk minus 1, whereby this can be defined as xk minus 1, right? Okay, now if this is the scenario, can I take this k up here, and this one, okay, I just straight away fix it, although it's not exactly same, but equal for the approximate, and therefore this become xk xk2 this minus xk minus 1. Okay, this is, we call it, that's a second equation. Okay, now we found, based on this equation, we can place 2 in 1, right? We can place the 2 in 1 here. Okay, we can substitute this 2 in 1, therefore the 2 in 1 we get for the pk minus 1, divide with the del x. Okay, xk minus 1 2 plus this one is a power 2, right? Remember, therefore I put a bracket here, xk prime xk minus 1 overall power 2. Okay, this we can simplify. Can you see this? There is a small simplification that we can be done. Therefore, when we use the simplification here, xk, I factorize this. Okay, this is 1 f prime xk square root, not a square. Okay, therefore in simple we can define the whole thing, and this one representation here, right? Del x, and since it's a power square root, automatically it will cancel off. Therefore we will get this as a something 1 f prime xk, and this one taken out as this, and which later we become a dx. Okay, for the one particular case we already done. Okay, but is there possibility for us to make it for all, this whole line? Okay, we found this, right? If the case for the length of plane curve for the pk minus 1 to pk, for this range I am able to use this formula to calculate, right? Therefore, is it possible for us to do for the whole length here? Imagine this is, we call it as a whole thing as a s. Okay, call it as a s. Now we can calculate that as a, okay, we can calculate that as a s limit, okay, del x approaching to the 0, and we combined all the combination here for the smallest as possible, 1 to f xk 2 for the del x, and this combination will give us b2a1 plus f xk2 dx. This is a x-axis. For the axis x-axis, okay, this is we are calculating based on the x-axis, right? Therefore now we already found a differentiation here, integration for the s. The s is a length of plane curve, and I want you to remember this portion because we're going to use this formula heavily later. Okay, we're going to use this formula again. I remind you, this is we're going to use very heavily. Therefore I'm going to use one more, ds to the dx. We can refer this formula as k. These two formulas we're going to use later, and there are various other combination. Remember, what I want you all to remember in this case is we are calculating, okay, we are calculating the length, and we are making as small chunk as possible. Okay, imagine there is a small chunk and we are calculating the length of each, okay, each line here. Okay, the combinations can be calculated based on this equation if the case is referred to the x-axis. This is, we call it as the length, the length of the line or curve. Okay, now for the s, it can be calculated for the b to the a 1. What is this? Actually is a dy dx. This is a dx. Okay, dx. Therefore it makes sense absolutely if we use y as a y-axis and yx base coordinate system. It will be like this. Okay, if we wanted to calculate not only this base based on the x, if you place your eye here, you can calculate for the base x, right? Sometime we can use our eye from y base. Okay, we can see from this and we can calculate. Therefore in this particular case we call it that as a dc. I can calculate based on the length which is a dx dy power 2 dy base. Okay, this is the dy base, and the combination also is possible. Sometime we used to calculate like if the case is something, one is a t basis, for example t basis, and x also is a t basis, t basis, x is a t basis. This is parametric. Okay, we can use a parametric base. Therefore, parametric. Okay, some of you bit very curious. Why are we changing? So far okay, what? Okay, but why suddenly we are changing to the another parametric? Okay, sometime we use not only x, y or x. We parameterize. Okay, we parameterize this to what we call ft. Okay, we parameterize this in the t form. Okay, this parametric based on calculations. Okay, therefore we know the calculation can be calculated for the dy dt. Okay, if you wanted to calculate dy dt, this is dy dt, this one is a dx dt. Okay, then when we substitute the whole dy dt, the equation can be summed up to parametric form, whereby okay, it can be calculated based on the t1. Okay, we use a t here. Okay, this we cannot use x anymore. Okay, we use a t. Okay, t1, t2 or t1. Okay, and the representation will be, initially we started everything with this, right? Okay, imagine we started with this. Okay, now the parametric is dy for the particular parametric. We will get a dx dt. Okay, dy dt square root. Okay, this easily can be proved. Okay, but I am not going to show you how to prove it. This is a very simple one anyway. Okay, we can use this combination, we can use the same logics, and we can prove this to the parametric. Okay, this three formula. Okay, remember this is y based. Okay, this is a y based, this is a x based, this is x based, this one is parametric. Okay, therefore these three formulas, including this one ds dx or ds dy, or it could be ds dt possible. Okay, later, but I won't go into too detail. You can see similarly you can find out the same formula that you can derive based on the ds dt. You bring it this to this side, you will get ds dt. Okay, and with this you should be able to calculate the length. Okay, we can able to calculate the length of any what you call the curve on the plane. Okay, now based on this calculation, let me give you one example. Okay, one example. No point we are spending more time for the it's very important, that's why I am emphasizing this of the curve, because later it's easier for me to explain the logics behind. Okay, from x, okay, can you see that? Okay, from x equals to 0 to x 4/3. Okay, this is obviously is a x base, right? The base is a x, then I'm looking from x base. Okay, y, that means I know already what is the formula to use, right? Now let me simplify this formula here. X 1/2 x 3/2. Okay, this is simple. And can I find out? Okay, because we are using dyd, right? Therefore the formula that we are referring to is what? This one, right? Okay, we are interested in this formula. Therefore, as very obvious, dy dx can be calculated, and this you will get it 3 to x 1/2, right? And okay, now we can calculate the s. Can we? Yes, we can calculate the s is 4/3, and to the 0 and 1, 3/2 x of 2 dx. Okay, when we cut it off, you will get a 3 over 2x here, and which will give us this equation as maybe I'll try to simplify that. 4 to the 3, 0, 1, 9 over 4x dx. Okay. Okay, how to solve this? How to integrate this? Is there any way to integrate this? Okay, you must learn the integration properly, because although it's not a coverage here in my syllabus, but I try to give you this by substitution. We can use this by substitution. Okay, by substitution we can solve this equation, this integration 9 over x. Therefore du can be calculated based on the 9 over 4 dx. Bring it up, bring it down, and you get a dx can be a 4 over 9 to the du. Is it okay? I hope that you can follow my face. And with this substitution, can I proceed? I just proceed here. Okay, just to save. Assume this is okay, substitution. I continue. Therefore, you will get a 4 over 3, 0, u, what? Half, right? Square root. You will get a half. D, cannot be. I cannot use this u, right, anymore. But assume, I don't want to place this immediately because I need to interchange this, okay? I need to substitute, I need to calculate here. But leave it here empty first for a while. And what is my du? Okay, it's a okay, 4 over 9 du. Okay, sorry, this we cannot later. Let us solve this first. After that we just substitute, no problem. Okay, later we substitute back this number. Is easy. Okay, now when we calculate this, this is, you will get it. Why am I making mistakes again? Okay, 9. Okay, this u half to the du, and 4 over 9, 2 over 3u, 3 over 2, because okay, you can differentiate that for this. Okay, now in the u form, I don't know what is this to substitute, right? Okay, you can substitute later, you can calculate this number, you want to put x, whatever, then directly you can just substitute, no problem. But anyway, you substitute back. 4 to the 9, okay, 2 to the 3, okay, I just substitute back again this as a 1 plus 9 over 4x. Okay, this is a 3 over 2. Now I can use back the whole equation, right? This is correct, Eddie. Again I remind you, I cannot place here 4 over 3. It's not referring to the u. Okay, because you want to change it, then you need to place it here. You need to place 4 over 3, calculate, and you need to place u, and 0, what you get is a 1, and then only you need to be able to calculate. Okay, once the calculation is made, then you can be able to finish this calculation. Okay, you will get it, the answer here. Okay, can you calculate that by yourself? As okay, maybe, I don't know, please check this. I don't know the calculation is correct or not. Okay, I will check, and you just substitute here, then you can use your calculator to calculate this. Okay, as simple as that. Okay, we have done. Okay, I'll give you one more example. Let me move into one more example. That is it possible for me to calculate for the parametric, because the challenging one is a parametric. Okay, at least I show you one example of parametric. Is it worth to continue? Okay, I'll quickly substitute. I'll just show you one example, very quick one. After that, Okay, maybe we'll see how much we can cover. Okay, now, okay, another example. This example, if x equal to the 3 over 3 t power 3 over 3, y equals to 3 t 2. Okay, this is very important. Let, okay, 0 t 1. Okay, this is the range that t can support. Okay, the range that t can support for the calculating. Okay, that means when we just say here 1, what is the x, here 0, what is the calculation for that. That's how you need to create the whole coordinate system for that, and you just sketch. But since we don't have time, I just show you this dx dt. It will give us 3 over 2 3, right? dy dt, just bring it down here, we get a 60. Okay, can I calculate the s? Yes. Okay, now the challenge is, I want you to see this. Okay, we know dx dt, this one is dt, sorry. Okay, dt to dy dt. Okay, dt. What is the range? Range is here. Can you see this? This is the range, 1 to the 0. Okay, if this scenario, this is the scenario, can I find the parametric solution? Yes, I can find the parametric solution. And the it's a parametric question. Actually, it's a parametric question, and I'm trying to solve with you. Actually, I forgot to write the question here. What suppose you want? I wanted to find. See, I forgot to write the question. I straight away solving this. Okay, I actually, okay, find. Suppose you need to find the parametric, find the s, parametric length. Okay, maybe the length of curve. Okay, place it here. Find the length of curve, or length of we call it as a plane curve. Okay, curve for the parametric, okay, for the parametric. Okay, if this is the case, okay, just I substitute straight away. Okay, just I can substitute straight away here. It's a 1 2. Okay, this is a 3t2 power 3. Okay, just no problem to solve this one. And this one here for the dy dt, we just substitute with the t, not x, so 2 dt. Okay, how to solve? Expand. Okay, the only choice you have is expand this. Okay, you cannot expect to solve this problem. Only way is to solve this is expanding. Okay, and t4 t2 9 t2. Okay, combine everything again. 9 36 t2 dt. Okay, when you simplify back the whole thing, okay, this is what you will get, 1 0. Okay, 94 19 t2, is it correct? Negative, yes, plus 9 dt. Okay, then you can substitute the whole thing, and you can able to solve the equation. Okay, is that possible for us to solve this? Okay. Yes. Okay, you can substitute that and you can able to do it that as well. The substitution, finally you will get it. Later I will show you one more way to solve this problem. This by substitution. Okay, by substitution the whole thing. Okay, is it by substitution can work or not? In this particular case, okay, I leave it to you to solve this problem anyway. But I'll give you the solution as this. Okay, yes, we can do this. And 0, another way to solve that as t2 plus 3, okay, to the dt. Therefore it can be cut off, can remove this, no need to do the substitutions here. Okay, dt and 3t to the dt. Okay, and the s can be calculated as 3t, okay, plus 3t 1 over 0. Then I hope that you can solve this rest of the things. Okay, I hope that you can solve the rest. Okay, now because I cannot spend more time here, okay, I cannot spend more time here. Therefore, because this is now you know how to calculate the length. Okay, this is a kind of introduction to the how to calculate this, because we're going to incorporate this knowledge inside our calculations for the what we call line integral. Therefore, in a simple, I get back to the topic again. Okay, now we get back to the method here. We learned the method 2, right? Okay, plus the method that we already learned is how to calculate the length. Okay, the length of, because later we're going to calculate the displacement. Okay, is slightly different from what you learned before in form 6 and your matriculation. Okay, in your matriculation you learn the length in a simple form. Okay, very straightforward. Now no, see, I already shown to you how to calculate the curve, right? Length of curve. Now we're going to find how to continue from there. Okay, now let me continue for this part. Okay, is there any possibility for me to calculate what we call as how to calculate I will introduce to you the method number, okay, method number 2. Okay, can I introduce to you the method number 2? Okay, this okay, the method number 2, because the first method, as I introduced to you this. Okay, now you see the method number 2, slightly we're going to go for something a little bit advanced. I continuing for the method number 2, line integral calculation. Therefore, some of you may ask, sir, we calculated up to here, we have done the length of curve. Are we continuing? Yes, we are continuing for the line integral, because that portion is we're going to incorporate later. In one of the method. Okay, one of the method. Now I'm teaching you method number 2. Okay, for the line integral method. Method number 2. Okay, this one is just intro to you. We won't use this at all. Just I'm introducing this method to just to inform you, saying that work can be calculated based on the vector f and displacement, just to give you just a kind of recall back the knowledge that you already have with you. Okay, now this is the actual calculation that I'm going to show you, how to calculate the vector for the line integral. Okay, the work can be calculated based on a certain concept. Let me introduce to you this. Okay, let f to be f1 I, f2 j, f3 k. Okay, this is a vector. Okay, as you all know, this is a vector. Okay, this vector is a force. Okay, it's a force carrier. Okay, it's a force carrier, as you all know. F, I already consider this is F. It's a combination of various forces. Okay, it can be a combination of the various forces on any particular object. Okay, then RT. RT is could be a parametric or maybe is a curve. Okay, curve on the xt. I will put it there as I. This also displacement, as you know, this is a 2tk. Okay, remember this is vector, this is also vector. Okay, remember again, I repeat to you, this is a vector, F is a vector, displacement also is a vector. Okay, it has a direction. Okay, it's a direction. The displacement has a direction. Therefore, when you use a vector times with a vector, you will get a scalar. Okay, now how to imagine this process? Let's say where I just place it, this is A, T, B with the, okay, let me put it to you, the logics. Maybe we draw. I'll draw for the 3D perspective. Okay, for the 3D perspective, let's say there is a charge is moving. Okay, Z, this is Y, this is X. Let's say there is a charge moving from here to here. Okay, there is a ghost. We introduce the ghost inside. What is this ghost anyway? This is the ghost. Okay, our vector here is going to carry this. Where is this line come from? This line is RT. Okay, this is a RT. Okay, it's a vector. Okay, this is a vector. This is the vector for the RT, and this ghost actually is F. Okay, various F is the overall total F. Okay, the ghost is actually, okay, I'll put it this as a ghost to you, for you to introduce to you the ghost. Okay, the ghost is ghost. Okay, the ghost, can you see that or not? Okay, yes. Okay, and how many combination? There are 3 combination of different various type of, it's actually, this ghost actually carrying 3 different forces. Okay, F1 could be any direction, no problem. I just wanted to tell you, okay, this could be in this direction, F2, and it could be F3. Okay, when the ghost moving on this or inside or whatever, okay, in this line, okay, it may give certain impact. Okay, it may give a certain impact to the other object. Later we'll know why. Okay, it may give other object some impact, right? Okay, because the charges, the movement of the charges can be calculated based on this. Okay, how do we calculate this? Okay, how do we calculate this? Okay, let me give you a simple intro to this. Okay, simple intro to this. Imagine you are moving in the line. Okay, on the line. The line can be a various combination. Okay, this is the point. The various forces coming inside. The forces can be in a various direction, can be in a different variations. Okay, this could be a different variations. Okay, F2. Our interest is just to make it this overall combination of this towards this, right? Okay, is it possible for us to calculate this F, okay, towards the R? Okay, because we need to move, along this line, because we are interested what is the total force that fall on this line. Okay, fall onto this line, because while it's the object is moving, we wanted to see how much force actually is carrying as well. Okay, therefore, is it possible for us to calculate this in the FR? Okay, maybe it's a R, I call it. Is it possible? This is a tangent line. Okay, we know this is a tangent line, okay, of the ghost. Okay, therefore, how to get? We already